All right, so you are an investigator for the police department, and they have sent you as a professional, physics-trained police investigator to come and inspect this crash. You see, they found a car that has run off of a cliff and crashed onto the ground. And they want you to figure out how fast the car was going before it fell off the cliff. They need to know this information. They need to know how fast the car was traveling right here before it left the cliff. They have no idea. They just see the wrecked car. So, what affects the speed of the car as it leaves the cliff? What things could you measure here in the present to figure out what's happening in the past? You, being a physics expert, simply walk up to the car and measure this distance. Then you measure this distance. And then you come back down. You grab out your calculator and your pencil, and you do this work. You measure this distance here, the horizontal distance the car traveled, to be 20 meters. And the measurement of the height that you measured was 32 meters. That's all the information you have. But you do know that vertically as the car fell, it fell at negative 9.81 meters per second squared. And you do know that the cliff is perfectly flat so that the initial vertical velocity was 0, meaning it didn't go off any jumps or ramps. It just shot straight out. So from this information, you need to calculate this. The horizontal velocity that it had before it launched, which will be the same velocity that it had here and here and here and here and here and here and crash. Right? Horizontal velocity doesn't change. So if you can find the horizontal velocity at the beginning, that's the horizontal velocity the whole time. That's what we're looking for. So we must first think, what equation helps us find the horizontal velocity of an object that is moving at a constant rate horizontally? So we think of the only equation that deals with constant velocity. And that is, the velocity horizontally is going to equal the distance it traveled horizontally divided by the time it took to fall from the peak. But the problem is, which one of those do we know? Only the horizontal distance. We do not yet know the time that it took. So we're kind of at a dead end, right? Because we weren't there. We couldn't actually measure how long it took to fall. But, again, you being an expert physicist, you know that any object falling off a 32-meter cliff on planet Earth with an acceleration of negative 9.81 will fall the same amount of time. So you say, all right, in order to find time, I need to find a new equation. So you look at the vertical motion of the car. You know vertically the height of the car before it fell. You know vertically the acceleration, but you don't know the peak time squared. Plus, you do know the initial vertical velocity is 0, but you don't know the peak time. So there we go. There's an equation that relates the acceleration, the height, and the time of any object falling. And if that object starts out at 0, vertically, velocity, it turns to 0. So here's our equation. To find the time, we first must do some algebra. So doing some algebra, we get the square root of 2 times delta D divided by A, and that equals our peak time. Now actually plugging in our gibbons, we have 2 times 32 meters negative, right? It fell 32 meters. It went down 32 meters. Divided by negative 9.81 meters per second squared. And that's going to give us the time it took to fall from the peak. So when we calculate this, we do the square root of 2 times negative 32 divided by negative 9.81. And we get out a time of 2.55 seconds. Right? That was probably the longest 2.55 seconds of that person's life that was driving the car. By the way, they were not injured. However, the police took them into custody, and they're waiting on your results to find out if he was speeding or not. Okay, so there we go. We now have the time that the car was in the air. We now have the time. And with that time, we can now plug it into this equation. So, the horizontal distance was 20 meters divided by a time of 2.5 seconds. 20 divided by 2.55 equals 7.84 meters per second. All right, there we have it. That is the speed the car was traveling as it left the cliff, which is not too fast of a speed, so the police will be able to let him go. All right, so there we have it. That's how you determine the speed of an object flying off a cliff if only the information you have is the height of the cliff and how far it lands from the cliff.